So, good morning, everyone. So today we start a new chapter that is called magnetism, and in this chapter, especially we go through uh, today we especially go through that part which already you know. That means which is very similar with the electrostatics. Okay, and then tomorrow uh, we discuss the next part, which is you can say in your board exam you have, but in entrance exam the whole part, the first part যেই পার্টটা এনসিইআরটি বইতে শুধু ফর্মুলা দেওয়া আছে, কিন্তু এইগুলো থেকে অনেক কোশ্চেন আসে। তো we start with first pole strength. Pole strength. See, the pole strength is represented by the symbol M. So suppose we have a magnet. So in this magnet we have a north pole and south pole. The convention is that north pole is represented by plus M and south pole is represented by minus M. Its SI unit ampere meter. And the most important part is that pole strength is directly proportional to cross-sectional area. What do you mean by cross-sectional area? That area. That area. Is it clear, everyone? Everyone, is it okay? Hello. Hello.
Yes, sir.
শুনতে পাচ্ছিস সর্বাণী? সর্বাণী,
হ্যাঁ স্যার।
তোর কিছু বলার আছে? So, see, we start the new chapter, that is magnetism. In this, the first one is the pole strength, which is represented by the symbol M. We have two pole, north pole and south pole. For north pole, we use plus M, and for south pole, we use minus M. And pole strength is directly proportional to the cross-sectional area, and its SI unit is ampere meter. So from that, one thing we can say that if we cut a magnet in this way, horizontal section, and if we cut a magnet in this way, vertical section and horizontal section. In vertical section, so my pole strength is remain as it is, but in the vertical section it will be half. I think all of you understand why. Because when we cross section is when we section is it vertically, so its cross sectional area remains same, but if we section it horizontally, its cross sectional area become half. Is it clear, everyone? সবাই বুঝেছিস? আরে হ্যাঁ না কিছু বল তো কমসে কম।
Yes, sir.
Second one is magnetic moment. Magnetic moment. Magnetic moment is represented by capital M, that is pole strength into separation between the two poles. So basically, in electrostatic, you have a charge. In magnetostatic, you have pole strength. In electrostatics, you have dipole moment P. In magnetostatic, you have magnetic moment M. In electrostatics, this dipole moment is charge into separation between the two poles. Here also pole strength into separation between the two poles. Now in electrostatics, the direction of electric dipole negative to positive, and here also the direction of magnetic moment negative to positive. Is it clear, everyone?
Yes, sir.
Okay. So now suppose we have a bar magnet plus M and minus M separated by distance 2L, and let M is the magnetic moment, that is M into 2L. Now suppose we cross section it's horizontally. Question number 1, find the magnetic moment of each in terms of capital M. Number 2, we section it vertically, find the magnetic moment of each section in terms of capital M. And the third one, we make it U shape, means semicircular shape. So the question is that find the magnetic moment in terms of M. So fill in the blanks. What is the value? 1, 2, and 3. Dekho, for the first one, obviously your M by 2, but the length is 12. So your magnetic moment is M by 2 into 12, that is ML, and here capital M is M into 12. So obviously this is M by 2. The second one, in the second one, this is a plus M minus M plus M minus M, but the length is L. So M into L, so this is M by 2. Now in this one, what happened? Poles M3 is pole strength into separation between the two pole, that is the 2R. Is it clear, everyone?
Yes, sir.
If this is M equals to M into 2R, and you bend the magnet in this way, so 2L is half circumference, that is pi R. So what is your R? R is 2L by pi. Is it clear, everyone?
2 by pi.
So it is 2M into 2L by pi. So 2 by pi M into 2L, that is 2 by pi into M. So this one is the third one, is very, very important for your entrance exam. Okay. Is it okay, everyone?
Yes, sir. Sir, लिखें एक तो.
Sir, হয়ে গেছে।
Now, if we want to compare, okay, if we want to compare, done, everyone?
Yes, sir.
Yes, sir.
If you want to compare,
सर
हाँ
तो लास्ट
अब
का
बोलो।
तो लास्ट का क्या था?
2 by pi M.
तो वीडियो बहुत ब्लर आ रहा है।
2 by pi M. Okay.
M ना?
M for magnetic moment of the first magnet. अच्छा, अब देखो, you can write electrostatics, you can write gravitation, you can write magnetostatic. For electrostatic, you have to charge particle Q1, Q2 if separated by distance R. For gravitation, you have to mass M1, M2 separated by distance R. For magnetostatic, you have to pole strength, that is suppose M1 and M2, two different magnet separated by distance R. Then in electrostatics, my force is 1 by 4 pi epsilon naught q1 q2 by r square. In gravitation, g m1 m2 by r square. In magnetostatic, mu naught by 4 pi m1 m2, that is the pole strength, r square. Obviously their units are different. Here the pole strength is ampere second, here the mass is kg, here the charge is coulomb. Now if you want to write electric field, that is 1 by 4 pi epsilon naught source charge particle by r square. Here the gravitational field is g source by r square, like in gravitational acceleration, sometime which is represented by small g also, g capital M by r square. And in magnetostatics, that is called magnetic field. So mu naught by 4 pi M by r square. Next is potential energy, 1 by 4 pi epsilon naught q1 q2 by r. Here the potential energy, is minus g m1 m2 by r. Why we use this minus? Because here the gravitational force is exactly opposite of the electric or magnetic force. So when similar pole repel in electric and magnetostatic, in gravitation it is the attraction. So work done just the opposite. External work done by this one and this one, they are just opposite. So here you take the value positive and here you take a value negative. Okay, you can remember in that way. And here again it is mu naught by 4 pi m1 m2 by r, and potential 1 by 4 pi epsilon naught q by r, scalar quantity, potential, gravitational potential minus gm by r. Here also mu naught by 4 pi m by r. Is it clear, everyone? So you can
Yes,
say
sir.
they are same, just with a very little difference. The difference is that in gravitation, these two you take negative sign because of this is the attractive nature. Okay.
এখানে QM আর M টা কি সেকেন্ড ইকুয়েশনে
এখানে
এর ক্ষেত্রে
এটাতে
ফিল্ড
এটা
তিনটারই ফিল্ড, ইলেকট্রিক ফিল্ড, গ্র্যাভিটেশনাল ফিল্ড আর ম্যাগনেটিক ফিল্ড।
হ্যাঁ
সো M1 M2 কনসিডার করে করছি দিয়ে M টা কেন বা
না না, আমি এখানে m1 m2 জেনারেলাইজ করেছি, এখানে দুটো হবে না। এখন এখানে যখনই ফিল্ডে যাচ্ছি তো আইদার ফর m1 on m2 or for m2 on m1. So you need the source charge particle. I already discussed all these things in electrostatics. It depends on the nature of the source. যেমন মনে কর গ্র্যাভিটি আর আমার মধ্যে, ঠিক আছে? So between me and earth, okay, so gravitational force is g m1 m2 by r square. But gravitational field, the source is, if I suppose due to earth on me, so obviously my source is earth. And if I suppose due to me on earth, then the source is myself. Is it clear? So আমি এই জন্য আগেই বললাম যে সোর্স m is the source. ঠিক আছে, এগুলো তো আগে ডিসকাস করেইছি। Everyone, is it okay?
Yes, sir.
Okay. Not only that, if you want to calculate magnetic, if you have a charge, okay, q, if x is the distance, electric force is 1 by 4 pi epsilon naught qx by x square plus r square 3 by 2. Hope you remember. Is it clear, everyone?
Yes, sir.
Yes, sir.
If you just imagine a mass whose radius is r at a distance x, then the gravitational field is g in place of q, you can use mass, the rest is exactly same. And if it is your plus, so the electric field is away. If it is your mass, then the gravitational field is towards. And if you use a ring, and if I is the current, then the magnetic field, that also you discussed in the magnetic field chapter. Anyone tell me what is the value? কত ছিল বল?
Unit by 4 pi 2 pi I by R.
I R square কত ছিল? mu naught by 4 pi x square plus R square 3 by 2 কত ছিল বলতো এখানে?
R square.
I R square ছিল না?
I R square. হ্যাঁ, I R square.
আর এখানে একটা 2 pi ছিল না অ্যাঙ্গেলের জন্য?
হ্যাঁ, থিটা থিটা।
So mu naught I R square by 2 x square plus R square 3 by 2. Is it clear? And that's why at the center, your electric field 0, gravitational field 0, but the magnetic field is not 0 if it is current, right? Okay. Everyone okay? This one?
So that also leaks.
এক মিনিট স্যার লিখে নি।
আরে এগুলো লেখাই আছে তো। এটাও লেখা আছে, এটাও লেখা আছে, আর কত লিখবি? অ্যাকচুয়ালি এটার ফর্মুলা ছিল আমার যতটা মনে পড়ছে mu naught I R into 2 pi R, তাই না শ্রাবণী?
হ্যাঁ স্যার।
সার্কামফারেন্সের জন্য 2 pi R নিয়েছিলাম। যাই হোক,
স্যার মাঝখানেরটা এটার মধ্যে এটা গ্র্যাভিটেশনাল। হ্যাঁ
হ্যাঁ, গ্র্যাভিটেশন না, গ্র্যাভিটেশনাল ইলেকট্রোস্ট্যাটিক্স একদমই সেম। আচ্ছা, আফটার দ্যাট I think all of you remember, if we have a dipole and this is the center, this is L, this one is L. So if P is the point, let it be plus M, this is the minus M, R is the distance. If you remember the electrostatics, then easily you can remember the magnetostatics. Mu naught by 4 pi. Anna, anyone tell me what? M into 2R by R square minus L square whole square for axial. Remember? Generalized form.
yes sir.
If R is greater than L, then Bx is mu naught by 4 pi 2m by R cube. And same thing for electrostatics, Ex 1 by 4 pi epsilon naught. Instead of m, you can write P into 2R by R square minus L square whole square. If R is greater than L, 1 by 4 pi epsilon naught 2p by R cube, right? And even for the direction also, they are exactly same. For axial position, net electric field and net dipole are in the same direction, right? Okay. Sharon,
Yes, sir.
is it okay?
आज मेरा नेटवर्क बहुत पिछड़ा है सर।
अच्छा ठीक है, you if you जितना देर हो रुको and then you see the video, okay?
Yes,
But आज का क्लास का वीडियो देखना, because so many information I'm trying to give you.
Yes, sir.
Okay. Now for equatorial position. Now for equatorial position. P is the point. So we all know the direction is in opposite direction. R is the distance, and don't need to derive all these things because already you know for magnetic field. Anyone tell me mu naught by 4 pi? What is the net formula? M ball.
R square
R square
plus
plus
L square
L
whole to
square.
the power 3/2.
Very good. So if R is greater than L, and believe me, you have to remember in that form. भगवान जाने कब कैसा फॉर्म दे दे, not necessary कि हमेशा वो ये वाला फॉर्म दे. तो try to remember in generalized form. Ey is also 1 by 4 pi epsilon naught P by R square plus L square 3/2, and Ey if R is greater than L, 1 by 4 pi epsilon naught P by R cube. Apart from that,
Opposite.
if we use a same opposite direction, same. If we use a at any position, okay. So this is my dipole. This is along P cos theta. Rohiter ki khabar hai? Dx. Shantanam.
हाँ सर
Rohit क्या phone laga? Rohit.
सर आज
So this is bx, this is by. I think all of you remember na? This is the resultant b. This angle is phi. Remember, in this type of situation, now I can write directly. My b is root under b of x square plus b of y square. So b is mu naught by 4 pi m by r cube.
1 plus
1 plus
3 cos square.
3 cos square theta plus 1 या 1 plus 3 cos square theta, where bx is this one, mu naught by 4 pi 2m by r cube, and by is mu naught by 4 pi m by r cube. and at the same time tan phi half of tan theta. Na?
हाँ.
And that same question याद है, question भी same था कि this is your magnetic field, theta is the angle, for one value of theta, the resultant makes an angle 90 degree with this. So the answer
सर
is
এটা কি লিখেছো
tan
r greater than
L.
ऐसा सर এই সাইডে ইস্ট সাইডে ইওয়াই এর সাইডে দেখো
अरे ये একই তো L
কি না ওকে ওকে স্যার ওকে
ताड़ाताड़ी लिखती है. याद है ना, ये क्वेश्चन भी कराया था, थीटा का which value, थीटा is tan inverse 2, थीटा is tan inverse root 2, theta is tan inverse half, theta is tan inverse 1 by root 2. Same question, answer is B. याद है? Resultant magnetic field makes an angle 90 with the line joining the axis of the dipole. For
सर
what value of?
क्वेश्चन था रघुवर.
अरे क्वेश्चन था, एक डाइपोल है साउथ नॉर्थ पोल which makes an angle theta. Resultant magnetic field makes an angle 90 degree with the line joining the axis of the dipole. For what value of theta it is possible? So you remember now, this is the Vx, this angle is phi, this angle is phi, this is 90 minus theta. Then we write V naught tan phi, half of tan theta. Remember now?
Yes, sir.
Tan phi is 90 minus theta, half of tan theta, cot theta, half of tan theta. So 2 equals to tan square theta. Tan theta is root 2, theta is tan inverse root 2. Same question electrostatic में भी कराया था.
ना सर, हमारा प्रॉब्लम था लोटा थीटा.
Okay, whatever. So the next one is very, very important, torque. Torque. देखो torque में क्या है? The same way we can say कि in presence of magnetic field, if we introduce a bar magnet plus M minus M, so this is plus MB, this is minus MB. This length is 2L. This angle is theta. So this is 2L sine theta. F1 and F2 equal in magnitude, opposite in direction. So net force is 0, F1 and F2 equal in magnitude, opposite in direction. So net force is 0. So no translational motion, but they are not in the same line of action. They are not same line of action. So they create a torque. They create a torque. The torque is force into perpendicular distance. So क्या था? MB sin theta. Remember now, everyone?
Yes, sir.
I'm not going to derive this all things. So if this is my MB sin theta, then the work done T theta, theta 1, theta 2. So we can put MB cos theta 1 minus cos theta 2. Remember, theta 1 stable equilibrium, theta 2 unstable equilibrium. Remember?
Yes, sir.
ये सब इलेक्ट्रोस्टैटिक्स हम लोग डिटेल में पढ़ा है. अच्छा. With this, if you want to find out the time period, that is 2 pi root under I by MB. I think all of you remember this part also.
সেটা
Yes,
কি
sir.
করে আসছিল?
ওমা আগের দিন করালাম না ওই যে টর্ক রেস্টোরিং টর্ক SHM
ও হ্যাঁ হ্যাঁ হ্যাঁ
and in electrostatic it is 2 pi root under I by PE. The only difference is here the I is as it is a bar magnet. So if the length is L, 2L, so moment of inertia of a bar magnet is 1 by 12. M is the mass, and here as we suppose the length is 2L, so 2L square. So what we have 1 by 3 ml square. Don't write 1 by 12 ml square because here we suppose the length of the bar is 12. Okay.
এটা মোমেন্ট অফ ইনার্শিয়া তো?
Moment of inertia. So after that, if we try some numerical, just some numerical, then we try the next part. See what happened. Everyone done?
একটু দাঁড়াও. এটা হয়ে গেছে.
Okay. So after that, let's try some numerical. Suppose I'm giving you two magnet. One is this one, South Pole, North Pole. Let it be the magnetic moment M1, which is 0.27 ampere meter square. Oh yes, one more thing. Magnetic moment M into 2L, as the SI unit of pole strength is ampere meter, that is ampere meter square SI unit. So 0.27 ampere meter square. And here you have a point P, which is at a distance, suppose 40 centimeter, and this one 30 centimeter, and you have a pole strength, South Pole, North Pole, M2, let it be, how much is given? 0.3 ampere meter square. Find the net, find the net magnetic field at point P. Find the net magnetic field at point P. Find the net magnetic field at point P. basic idea is here, south and north pole. So this is my magnetic moment. So this is the equatorial position. So this is my B1, and here the south and north. So my magnetic moment is this one. Now,
স্যার আমার জেনারেল ইকুয়েশনটা সেটা বলবো কি
হ্যাঁ বলো।
নিউ নট বাই 4 পাই তারপর রুট তারপর হলো হচ্ছে m1 বাই
u
r1
naught by 4 pi মানে 10 to the power minus 7, আর এটা হচ্ছে ইকুইটোরিয়াল, এটা হচ্ছে ইকুইটোরিয়াল। So m1 0.27 by that distance is 0.4 square, তাই তো? আচ্ছা 4 কিউব, তাই না? তাই তো? Hello.
হ্যাঁ স্যার
So basically what you have 0.27 by 4 cube মানে 16 64 না, 16 into কত হয়, 16 into 4 64 into 10 to the power minus 3 into 10 to the power minus 7. So approximately 0.27 by 64 into 10 to the power minus 4 Tesla. And the B2 is, I'm just give it randomly, so maybe the data a little bit vary, minus 7, 0.3 by that distance is 3 into 10 to the power minus 1 to the power cube. So 0.3 by 27 into 10 to the power minus 3 into 10 to the minus 7. So 3 by 27 into 10 to the power 8 থেকে গেল মানে minus 5. So 1 by 9 to the minus 5 Tesla. Now as you get this to value, so the resultant is, although देखो the problem मैं फिर से बोल दिया कि मैंने डायरेक्ट CGS को SI यूनिट में कन्वर्ट किया है, ऐसे वैल्यू दे दिया रैंडमली, इसलिए ये प्रॉब्लम हुआ. So in examination they can give you such a way that you can get the answer easily, and then you can
ভ্যালু গুলো বাজে এখানটা না
ভ্যালু তো আমি নিজে আন্দাজে এমনি ফট করে চেঞ্জ করার জন্য দিলাম। অ্যাকচুয়ালি এখানে ভ্যালুগুলো সিজিএস ইউনিটের গসিয়ান ফর্মে দিয়েছিলাম, আমি ওটাকে জাস্ট চেঞ্জ করে দিয়েছি। Is it okay everyone? Hello.
ইয়েস স্যার
Okay. So the next one is suppose you have a magnetic field BH and you have two bar magnets, south to north, and you have one more bar magnet. South to north. Let it be the magnetic moment is M1 and let the magnetic moment is M2. It is given M1 is equals to 3M2 and the angle between them is 90 degrees. If M1 makes an angle theta with the BH, then find the angle for which the system is in equilibrium. Means for what value of theta the system is in equilibrium. Option A, theta equals to tan inverse 3. Option B, theta equals to tan inverse 1 by 3. Option C, theta equals to tan inverse root 3. Option B, theta equals to tan inverse 1 by 3. Try this question.
angle between m1 m2 is 90 degree
System is in equilibrium. That means this is the magnetic moment. We know very well that torque is magnetic moment into magnetic field. So for this one, torque is upward, and see this one downward. So this torque, this one torque this one torque and this one torque, they are clockwise and anti-clockwise, means balance each other. Is it clear?
Yes, sir.
স্বর্ণদীপ বুঝছিস?
আচ্ছা স্যার, তুমি
Normally-
ডিরেকশনটা কিভাবে নিচ্ছ এখানে টর্কের ক্ষেত্রে?
রাইট হ্যান্ড কার্ল রুল, ম্যাগনেটিক মুভমেন্ট ম্যাগনেটিক ফিল্ডের দিকে ঘুরবে।
স্যার অপশন ডি হবে কি থিটা ইকুয়ালস টু tan ইনভার্স 1/2?
1/3, হ্যাঁ।
আবার 1/2
আমি
আছে।
না 1/2 না 1/3 আছে তো, এটা 3 না 2? এখানে 3 নিয়েছিস না 2 নিয়েছিস?
এটা 3 স্যার।
3 নিয়েছি।
তাহলে কি করে 2 আসে? দেখ, torque 1 is equals to torque 2. Is it clear, everyone?
Yes, sir.
If this angle is theta, so then this angle is 90 minus theta,
90 minus theta.
because the angle is given 90 degree. So for the first one, m1 bh sin theta, and here m2 bh sin 90 minus theta. Is it clear, everyone? Can we write this?
Yes.
So bh cancel. First of all, m1 is 3m2 sin theta, that is m2 cos theta. So tan theta is m2 by 3m2, that is 1/3. So theta is tan inverse 1/3.
স্যার
Okay.
দুটোর জন্য ম্যাগনেটিক ফিল্ড BH?
এই যে BH কমন, এটা ম্যাগনেটিক মোমেন্ট 1, ম্যাগনেটিক মোমেন্ট অফ BH is common.
ওইটা দুটো রেজাল্টেন্ট না B1 plus B2?
না এইটা তো ম্যাগনেটিক মোমেন্ট m1 m2, আর এটা তো ম্যাগনেটিক ফিল্ড। ম্যাগনেটিক মোমেন্ট আর ম্যাগনেটিক ফিল্ড এক কি করে হবে?
ও একটাই ডিরেকশন।
In presence of magnetic field, if you place a magnetic moment, তবে তো টর্ক হবে না।
হ্যাঁ।
ঠিক আছে? So this is one type of question examiner can ask you. Sometime examiner can ask you one more type of question where they can put you two magnetic fields. Try to understand. Okay, they can put you two magnetic field. Suppose B, and this is B1, and this is B2, and then they can ask you B1 is 3B, B2, that is the relation, and they can put you a magnetic moment, a magnetic needle basically. They can put you a magnetic needle like South Pole and North Pole. Yeah, North Pole and South Pole. Is it clear, everyone? If this angle is theta, now they can ask you for what value of theta the system is in equilibrium. Got it? Got it?
স্যার
Yes, sir.
So see, the North Pole, that means plus M, and South Pole, that means minus M. So if this is my magnetic moment, here we have force this one, here we have force this one. So again, that same thing, torque and all these things, right?
ম্যাগনেটিক মোমেন্টে ইকুয়াল এখানে।
হ্যাঁ, তাহলে এখানে আমি ধরবো let it be the torque 1 and let it be the torque 2. For torque 1, here we can write B1. মানে
সেম কোশ্চেন আছে ইকুইলিব্রিয়ামে কত থিটা হবে ওটা?
same question, but the questions are different. Here you have two magnet and one magnetic field. Here you have two magnetic field and one magnet, and it is given क्या लिखा था B1 equals to 3B2 ना?
হ্যাঁ
Hello?
স্যার।
That can be changeable, but you try to understand the concept. Concept is that this is the magnetic moment. So magnetic moment into B1 equals to magnetic moment into B2. So if we suppose this one angle is theta, so MB1 sin theta, that is MB2 sin 90 minus theta. So what you have, B1 sin theta, that is B2 cos theta, 3b2 sine theta b2 cos theta tan theta is 1 by 3 theta is tan inverse 1 by 3. You can change this. আমি যদি b2 কে b2 equals to b1 করতাম, so then this one can be varied. So my basic idea is only this one. This is my basic idea. You understand? A torque 1 balance the torque 2. Is it clear, everyone? Hello,
Yes, sir.
everyone.
Yes, sir.
Is it okay? Okay. Apart from that, देखो अगर मेरे पास suppose we have a magnet wrapped with some string and placed in presence of magnetic field B, south pole, north pole, theta is the angle, magnetic moment is this. We already know the time period of oscillation of the magnet is 2 pi root under I by mb. Is it clear, everyone? We know this one.
Yes, sir.
Let m is the mass of the bar magnet, 12 is the length. So now the question is that
blur
which
হয়ে গেল।
examiners, ঠিক আছে? ঠিক আছে কি?
হ্যাঁ স্যার।
Now the question is that now two type of section can be possible. Case one, if you make it in vertical section, okay, and case two, if you make it in horizontal section. Question is find time period So one is the vertical section end part, another one is the horizontal section end part. Now the question is find the time period for each section. For each section. Matlab, initially the magnetic moment is m. Now if you make it n part means suppose you make it 3 part. So then what is the time period of each part? Same in presence of magnetic field, or you make it horizontal section 3 part or 4 part or 5 part or n part. So what is the magnetic, what is the time period for each section? This is the question. Is it clear, everyone? Hello? Anyone understand the question? Hello?
স্যার এই টাইম পিরিয়ডের ফর্মুলাটায় কি কনস্ট্যান্ট থাকে আর কি থাকে না?
আমার কথা ছিল না, আমার কথা আমি যে কোশ্চেনটা দিচ্ছি কোশ্চেনটাকে বুঝেছিস?
হ্যাঁ, রডটা এন পার্টসে ডিভাইড করার পর তখন
In presence of same magnetic field আমি পুট করছি, তার মানে my B is constant. In presence of same magnetic field we put each part, horizontal end part or vertical end part, okay, so that they can give you the question. Then the new time period of each section is option A T, option B T by N, option C N T, option D T by N square. You can write option E also, N square T, like this. You understand?
স্যার কেস 1 আর কেস 2 আলাদা আলাদা হবে?
হ্যাঁ, মানে কেস 1 এর একটা হবে, কেস 2 এর একটা হবে। আমি মানে দুটো এইভাবে পাঁচটা অপশন, মানে ফর দিস কোশ্চেন দিস অপশনস আর ভ্যালিড, ফর দিস কোশ্চেন দিস অপশনস আর ভ্যালিড,
আচ্ছা
ওকে? সো ইউ আন্ডারস্ট্যান্ড দ্য কোশ্চেন না ফার্স্টে?
ইয়েস স্যার।
Now see how you solve this type of question. Let's try for the first, for the vertical section. So let T1 is the time period, 2 pi I1 M1B, because in presence of same magnetic field. Are you getting it? Is it okay for everyone?
স্যার
Everyone?
Yes, sir.
Pranadip,
Sir.
বুঝেছিস তো? শান্তনম, দিশা, দীক্ষা.
হ্যাঁ স্যার।
Now see, what about M1? Obviously we know if we make it N section, my magnetic moment is M by N. Is it clear, everyone? Can I write this?
ইয়েস স্যার।
And my initial magnetic moment of inertia is 1 by 12 M. I can suppose it L instead of 12, or I can suppose it 12, no issue, 12 square. Is it clear?
ইয়েস স্যার।
So my moment of inertia is 1 by 12 M. Now it's an N part, so obviously my mass become M by N. Is it clear?
ইয়েস স্যার।
So moment of inertia ফর্মুলাটা দেখিনি আগে আমি।
রডের ফর্মুলা জানিস না? 1 by 12 ml square.
এটা রোটেশনাল ডাইনামিক্স।
আচ্ছা,
তো 1 by 12 M by N রোটেশন করিয়ে দেবো, চাপ নিস না। এখন শুধু এটুকু মনে রাখ, রডের জন্য 1 by 12 ml square হয়, এলটা এখানে 12। তো 1 by 12, now the mass is M by N and length is also 12 by N whole square. Are you getting it? Is it clear, everyone?
Sir.
ইয়েস স্যার।
Everyone is okay? So overall, if we compare with this 1 by 12 M 12 square, if we kept as it is, we can say I by N cube. Can we say that?
হ্যাঁ, ইয়েস স্যার।
So my T1 is 2 pi, I1 is I by N cube, M by N into B. So basically everything is same. We have 1 by N square, that we, if we make it outside, so I by NB, that means time period is T by N for each part. Is it clear?
হ্যাঁ স্যার।
Similarly, if we suppose about T2, let it be 2 pi I2 by
স্যার আমাকে
N.
দেখালে ফর্মুলাটা মনে রাখতে হবে না, T1 equals to T by N।
হ্যাঁ, মনে রাখতে হবে, হ্যাঁ হ্যাঁ হ্যাঁ, কিন্তু মানে ব্যাপারটা একটু জেনে রাখাও ভালো না, কি করে এসছে। গাধার মতো কত মনে রাখবি? মনে রাখবি, কিন্তু প্রসেসটা জানা থাকলে বেশি সুবিধা হয়। ইজ ইট ক্লিয়ার? বুঝতে পারিস কি জায়গা ব্যাপারটা?
হ্যাঁ স্যার, বুঝতে পেরেছি।
নাও সি I2 by M2B. নাও তুই বল M2 কত হবে এখানে ইন টার্মস অফ M? স্বর্ণদীপ বল।
এম বাই এন।
M by N হবে, স্বর্ণদীপ হবে না?
হ্যাঁ স্যার।
মোমেন্ট অফ ইনারশিয়া আবার কত হয়ে যাচ্ছে? See the moment of inertia, 1 by 12, mass is N time divide, right? Can we write M by N?
ইয়েস স্যার।
And but the length is remain as it is. Length is
ইয়া
not
12 স্কয়ার হোল স্কয়ার।
12 square. So basically what happened? Moment of inertia is I by N. Is it clear?
হ্যাঁ স্যার।
এখানে দেখ না, এরকম যখন করেছি আমার লেন্থটাও n টাইমস কমে যাচ্ছিল না, এখানে লেন্থটা কিন্তু একই থাকবে। তাহলে টাইম পিরিয়ড 2 is 2 pi I by n m by nb, তাহলে nn কেটে যাচ্ছে, 2 pi root under I by mv, তার মানে টাইম পিরিয়ড does not change, it will remain same. So it's a lovely question. Sometimes they can give you the vertical section, sometimes they give you the horizontal section. You just remember, if the length is same, so the time period is same. If the length is n times half, so the time period is n times, right? মানে simply এখান থেকে আমরা একটা কনক্লুশন পেলাম, time period is directly proportional to n times, মানে length, তাই না? লেন্থ ছোট হয়ে গেল, n টাইমস ছোট হয়ে গেল, টাইম পিরিয়ড কমে গেল, লেন্থ সেম থাকলো, টাইম পিরিয়ড সেম, তাই না?
তো দুটো কেসই হবে তো?
হ্যাঁ, আর কি কেস হতে পারে এখানে, মানে স্পেশালি এটা অন্যান্য কেসে অন্যরকম হতে পারে, বাট এইটাতে অ্যাটলিস্ট এটুকুই হবে, ঠিক আছে?
হ্যাঁ স্যার।
चलो कल हम लोग सेम मिलते हैं।